Class Test 2, Question 6. Determine the complex conjugate of Z1. Z1 equals 3 plus J, so the complex conjugate is 3 minus J. The complex conjugate means you just change the sign of the imaginary part. So if the imaginary part is positive, the complex conjugate is negative. If the imaginary part is negative, then the complex conjugate part is positive. Now find the product of Z times Z star. Before we do this, remember that A squared minus B squared is equal to A plus B times A minus B. We've got 3 plus J times 3 minus J. So from that we get 3 times 3, 3 times minus J, then we get J times 3 and J times minus J. J squared is equal to minus 1, so minus J squared is equal to 1. 3 squared is 9, so that's 9 plus 1 is 10, and we've got a minus 3J and a plus 3J, so they cancel each other out. So 9 plus 1 equals 10, and that's the product of a complex number by its conjugate. The key issue here is that when you do this, you will always end up with a real number. Question 3. Determine the quotient of Z1 over Z2. We have a complex number in the denominator, and the way to get rid of that is to multiply top and bottom by the complex conjugate of the denominator. So we're going to multiply these two together, and actually if you think about it, you can do this just by looking at it. It's going to be 2 squared plus 3 squared. If you don't believe me, expand it longhand and you'll see what the answer becomes, but 2 squared plus 3 squared is 13. And then we're going to get 3 times 2, which is 6. We're going to get 3 times 3j, which is 9j. Then we're going to get j times 2, which is 2j. And then we're going to get j times 3j, which is 3j squared. So j squared is minus 1, so that becomes 6 minus 3. And 9 plus 2 is 11j.